Hi students, welcome to another video about Lewis structures. This is the fourth video in our series and the second to last one. You're almost there, so keep at it. In this video, we are going to be covering XeO3. And the reason for this is because XeO3 is a little bit more complicated than CO2. So we're going to be covering all of the same steps that we went through for CO2, but you'll see that there are a lot more nuances to it that we can see in XeO3. So the first step in our checklist is to identify the central atom of XeO3. And so in this case, it's xenon, so Xe, because that's our most electropositive. In that case then, our three O's are our peripheral atoms. So now that we've identified our central and peripheral atoms, we are going to be calculating the steric number. So you can already see at the top there, we have our steric number formula, which reads that steric number is equal to the valence electrons from the central atom plus the contributing electrons from the peripheral atoms, subtracting charge. And so in this case, we have 8 valence electrons from our central atom xenon, and then we need to revisit that handy-dandy chart in our left-hand corner here, which gives us the contributing electrons from our peripheral atoms. So in this case, we have the exact same peripheral atoms as we did for CO2, O, and in that case, they donate 0 electrons, and so we can just add a 0 there. Next, we have to subtract the charge. And so in this case, xenon O3 is a neutral molecule, and so we subtract 0 again. All of this is divided by 2, and that reveals that our steric number is 4. So now that we have our steric number, we can compare that to the number of peripheral atoms that we have. And in this case, we only have 3 peripheral atoms. And this tells us that even though we have a parent structure where Sn is equal to 4, we have the parent minus 1 structure that will represent the true structure of our molecule here. And so let's revisit that. So here we can see in this chart on the left-hand side that there's the parent structure names, and then what the different parent minus 1, parent minus 2, and parent minus 3 structures look like. And in this case, like I said, we have Sn equals 4, but we have the parent minus 1 structure, and so our structure is trigonal pyramidal. So now that we know what the shape of our molecule is based on the steric number, we can put all of the atoms together in the framework for trigonal pyramid. And so in that case, we still actually need that picture. So we can see that we have our central atom in the center, and then we have our peripheral atoms arranged as if they're in a pyramid. The last electron group that we have is to the top, because that's where an atom would have been had we had our parent structure. And so let's take a look at what happens next. We've connected all of our atoms with a single bond, and so now we need to fulfill the octet rule for our central atom. So like I said, we would take a look at how many electrons are already around our xenon, and so that's 6. But now we need to add one more lone electron pair, and so that ends up right at the top, where an atom would have been if we'd had the tetrahedral structure. So now that we've fulfilled our octet rule for the central atom and given it 8 electrons, we need to fulfill the octet rule for our peripheral atoms. So our peripheral atoms, oxygen, currently have 2 electrons each because they have that one single bond. And so that means we need to add 3 lone electron pairs to each oxygen. So now we can see that we have 8 electrons around each of our oxygens. And so the next step is to minimize formal charge. So formal charge, as a reminder, is calculated with the number of valence electrons around the central atom, subtract, in brackets, the number of bonds plus the number of lone electrons. And so in this case, let's do it first for xenon in the center. So xenon here has typically 8 valence electrons around it. But in this case, we have 3 bonds, 1 to each of the oxygens, and then 2 lone electrons. And so that's 8 minus, in brackets, 3 plus 2, which is 5. And so that's 8 minus 5, which is equal to 3. And so now that we have, for the first time, a non-zero formal charge, we need to add that onto the molecule. We missed mentioning in the last video that 0 formal charges are not added to molecules. So now that we have the formal charge for xenon, let's calculate the formal charge for each of our oxygens. So we have typically 6 valence electrons around the central atom, but in this case we have 1 bond plus 6 lone electrons. So this is 6 minus 7, which gives us -1. And so each of our oxygens here have a formal charge of -1. And so now let's see if we can check our final structure to see if it's the correct structure. So another tip about formal charge that you might need to know is that the sum of all of our formal charges will equal the charge of our molecule. So as a reminder, we started with a neutral molecule. And so here we can see that +3 from the xenon plus each of the -1 from each of the oxygens will give you a neutral overall charge, and this is correct. Other ways that we can check whether we are correct are to go through our 3 main rules: steric number, fulfillment of octet rule, and minimized formal charge. And so we already just checked formal charge, but if we take a look at steric number, we can see that we do indeed have 4 electron groups around our xenon. And so we know that it's correct. So had we not had the lone pair, this would have been an incorrect structure. Or if we had put the lone pair in one of the bonds to the oxygen, for example, that would have been incorrect. Next, we need to check the octet rule. So we can see here that all of our atoms have 8 electrons each. So xenon there has 1 lone pair and 3 bonds with 2 electrons each, so that totals 8. And then each of our oxygens there have 1 bond with 2 electrons and 6 lone electrons. So this would have been incorrect, for example, if we had missed any of the lone electron pairs on any oxygen. Finally, we minimize formal charges. And so in this situation, what's happened is that if we were to change any of the bonds and change, in essence, the formal charges of the molecules and atoms, we would have had to violate the octet rule or steric number. And so in this case, we know that our formal charges have already been minimized because we are fulfilling steric number and octet rule, and changing anything would change them.